Hi students, today we will discuss lens maker's formula. So this is a very important concept and also derivation for the purpose of your coming board exam. So you see, what is a convex lens? So we have two refracting surface of the convex lens. So here for the lens maker's formula, if two refracting surfaces are joined together, then what will be the relationship between the refractive index of the lens and the object distance and the image distance, focal length and the radius of curvature. So this is known as your lens maker's formula. Okay, so now you see, suppose we are drawing, this is a convex lens. So this is your principal axis. So here you see, as the aperture size will be very small, that we consider, and we can consider here two refracting surface. One is ABC and another one is ADC. So suppose we are considering the first surface, that is ABC. So this is your rarer medium. So rarer medium means this is mu1. So this will be also the rarer medium. So the refractive index is mu1. But inside the lens, the refractive index, that is the material of the lens. So this this is your mu2, the refractive index of the lens. So now we will be drawing the ray diagrams. So first you see, suppose we are having a point object here. So this is the incident ray. Now the incident ray will divert from its path as the ray is moving from rarer to denser. So if I draw the normal at this surface, so suppose this comes here. So this is the normal for the first surface. So I'll write this one as C1. Similarly, this will go like this, but rarer to denser, so it will be close to the normal. So it will move like this, right? Now again, from denser to rarer, so it will move like this. So suppose what we are getting, suppose we are considering the first surface only, the refraction at the first surface. So for the refraction of the first surface, what we will get? We will get the ray like this, right? So this will be the object and image for the first surface. So object is here, the image is here for the first surface. Similarly, if we consider the second surface refraction, so for that, this image formed by the first refracting surface will behave like a virtual object, and the final image will be formed, suppose somewhere here. The final image will form somewhere here. So this is your final image point, right? So I think it is clear to all of you. Now you see, for this point, this is the second surface, so we can draw the normal. So here the normal we can draw. So let the normal at this point, so this is drawn. So this point, this is your C2, right? So this is your normal, so this is your N, this is your M, and these are the two refracting surfaces. So I think now the ray diagram is clear to you. Now you see the object and this optical center. So the distance, this will be the object distance, and here for the first image formed by the first refracting surface, let that is your V1, and the final image distance, let this is your V, and you know the center of curvature for C1, this is R1, and this will be for C2. So for C2, this will be your R2, right? So all the distances we have measured. So now how to derive the lens maker's formula? Here you see, for the first surface, that is for the refracting surface ABC, object is at O and the image is formed at I1. So this image will behave like a virtual object for the second refracting surface, that is ADC. So in this case, you can visualize that the ray is moving from denser to rarer, whereas from the first refracting surface ABC, the ray is moving from rarer to denser, right? So here we can put the refraction at a spherical surface formula. So for the first surface, if we considering refracting surface, that is your ABC. So here the ray is moving from rarer to denser. So we can write your mu2 by V. This will be mu2 by V minus mu1 by U. That will be equal to mu2 minus mu1 upon R. So first surface, so R will be your R1, right? But here you see the object distance we have considered V1. So I will write here V1. So let this is equation 1. Similarly, by considering the refracting surface, that is your ADC, refracting surface ADC. Here you see the object is at I1 and the final image is formed at I. But here the thing is that the ray is moving from denser to rarer, from denser to rarer. So here the formula will be, you know, we have to interchange the mu1 and mu2. So we will get here mu1 upon final image, that is your V, minus mu2 upon U. Here object distance will be your V1 because this is for the second surface. So this will be equal to again mu1 minus mu2 upon second surface is R2. So let this is equation 2. So to have a common formula, that is if we combine these two refracting surfaces, so this refraction at two surfaces can be added. So by adding your equation 1 and 2, we'll get equation 1 and 2. What we'll get? Here you see this plus this. So mu2 upon V1, mu2 upon V1. So this will be plus and minus, so this will cancel out. So we'll get only mu1 upon V minus mu1 upon U is equal to, here we can take mu2 minus mu1 as common. What we'll get here? Here we'll get 1 upon R1. Similarly here you see mu1 minus mu2. So if I rearrange this thing, this will become as mu2 minus mu1 minus sign. So here I will put minus. So this will be 1 upon R2, right? So this is the required lens maker's formula if we combine the two refracting surfaces. So I can rearrange here. This will be 1 upon V minus 1 upon U. So this will be equal to mu1 will be taken that side. So this will be mu2 minus mu1 upon mu1 into 1 by R1 minus 1 by R2, right? So this way we can simplify the formula for the lens maker's formula. So this is known as your lens maker's formula. Here different conditions you can put. Suppose the object is at infinity. So your image is formed at focus. So you can write this one also. So by putting these conditions here, we will be getting 1 upon f minus 1 upon infinity will be equal to mu2 minus mu1 upon mu1. This will be 1 by R1 minus 1 by R2, right? So here we will be getting that 1 by f is equal to mu2 minus mu1. So that you know this will be mu2 1, that is the refractive index of the prism if one medium is your AR, right? So here I can write mu minus 1 into 1 upon R1 minus 1 upon R2. So these are the two formulas for lens maker's formula. So by using this formula we can find out the required things, right? So I think this derivation is clear. This is very important derivation for the CBSE exam 2025. Thank you.